In this lesson, we are going to look at the Young's double slit experiment. I'm not going to go into the details of the experiment, just I'm going to derive the formulas that we are going to use in double slit experiment. So, to understand this lesson better, I recommend you to first look at phase difference, for example, constructive interference, destructive interference, and maybe also you can look at the diffraction of the light. Okay, let's now go to derivation of the formula for the double slit experiment. Now assume a light is incident on two slits, and now this monochromatic light is going to pass through these two slits, and they are going to act like sources of light. Remember from the Huygens principle, the light from this source will diffract, and light from this source is going to diffract, and they are going to interfere, and we are going to have a pattern, interference pattern. Then if we put if I place a screen, on the screen we are going to observe some fringes. We are going to observe bright fringes, bright, dark, bright, dark, bright fringes. So, but there is not a sharp difference between the bright and dark fringes. Actually, at the center of the bright fringes, the intensity of the light is maximum, and at the center of the dark fringes, the intensity of light is minimum. So we are going to have such a change of intensity of light for the dark and bright fringes. So to understand the topic better, now let's remove the excess drawings. And okay, so we have two sources of light, this one and that one. This is a line connecting the center of the slits to the screen, and assume now two light waves, one from this source and one from this source, are propagating, and somewhere on the screen at this point, are we going to have a constructive interference or a destructive interference? It completely depends on the path difference of these two lights. To see the path difference between the light from here to here, we are drawing a perpendicular line from this source to here, and these two lines are going to be equal to each other. We assume that they are parallel to each other. Why? Because the slit separation is really small when compared to the distance between the slits and the screen. If this is D, and if this is A, the slit separation is A, so A is very small than D. In this case, we can assume that these two lights are parallel to each other. Anyway, this is the path difference. We will call it delta L. Depending on the amount of the path difference, we are going to observe either a constructive interference or a bright point here, or a destructive interference or dark point. So if delta L is equal to multiple integer of the wavelength of the light, we are going to see a constructive interference. CI is for constructive interference. In this case, the M is equal to 0, 1, -1, 2, -2, and so on and so forth. At the center of the screen, the light from this source and from this source will have the same distances, so path difference is going to be 0 in this case. Here we are going to have M is equal to 0, and above this level the fringes are going to be called positive fringes, and these are going to be the negative fringes. That's why here I have negatives to represent the fringes below this level. What about the destructive interference? If delta L is equal to M plus 1 over 2 lambda, in this case the destructive interference is going to take place, and M again is going to be 0, 1, -1, 2, -2, and it will continue like this. Now look at this triangle. In this triangle, assume this angle is theta. What is sine theta? Okay, sine theta will be equal to, if you look at this triangle, it will be A. Sine theta is going to be equal to delta L over A. So from here we can write that the path difference is equal to A sine theta. Similarly, we are now going to look at this angle. This is also a small angle, and it is also theta, and this angle is the angle in this triangle. Look at this triangle, please. And for this triangle, what is sine theta in this triangle? Assume this distance from this point to the center is y. Let's call it y. And sine theta will be equal to approximately to the tangent theta because of the small angle approximation. I mean tangent theta is y over d, but sine theta here will be y divided by hypotenuse. But if these angles are very small angles, in this case this d and this hypotenuse are going to be approximately equal to each other, then there is going to be no difference between y over d or y over this distance. They are going to be approximately equal to each other. That's why instead of sine theta we can write tangent theta, and from here tangent theta is going to be equal to y over d. So for the bright fringes we can find the place of the bright fringes, I mean this distance, by combining this formula sine theta is equal to y over d with, for example, this one. And we know that delta L is equal to m lambda, and this delta L is equal to a sine theta. So let's write this formula to here. Okay, delta L is equal to m lambda. Instead of delta L, I'm going to write a sine theta. A sine theta is equal to m lambda. So from here, instead of sine theta, I can write y over d. So a times y over d is going to be equal to m lambda. So m lambda is for a constructive interference and it is for a bright point. That's why y for bright interferences, yb, is going to be equal to m lambda d over a. I rearranged this formula and I called the y, this is, if this is a bright point, y bright is going to be equal to this one. What about for dark fringes? In this case, delta L, I'm going to write delta L is equal to m plus 1 lambda. And delta L, we know that it is a sine theta. So a sine theta is equal to m plus 1 over 2 lambda. And we know that sine theta is equal to y over d. So from here we can write a y over d equals m plus 1 over 2 lambda. Okay, if we rearrange this formula just like this one, if we rearrange this formula, we are going to get, let me write it here, y dark is going to be equal to m plus 1 over 2 lambda d divided by a. So on the screen for the distance from the center to a dark fringe, you are going to use this formula to locate the location of the dark fringes, and we are going to use this formula for the bright fringes. One more issue related to the formulas of the double slit experiment is the the fringe separation. So if we have on the screen, if we have dark and bright fringes, what is the distance between the fringes? For example, this is our screen, okay, and in this region, for example, we have a bright region, and this is a dark region, and this is also a bright region, okay, and I'm not going to draw the others. Now assume this is the center, and here m is equal to 0. Now what is the fringe separation? I'm going to call the fringe separation x. Okay, so assume this is the fringe m. Let's call this one m. This is going to be m plus 1. Okay, so let's calculate the distance for the distance from the center to this fringe, and the distance from this distance from the center to this fringe. To locate x is going to be equal to ym plus 1 minus ym, and so x is equal to, what is the, assume these are the bright fringes. For the bright fringes we said that y bright was equal to, for the bright fringes, y bright is equal to m lambda d over a. So now this is m plus 1 fringe. I'm going to write m plus 1 lambda d divided by a. This is ym plus 1 minus ym. It will be m lambda d over a. So if we do this math, we are going to see that x is equal to x is going to be equal to lambda d over a. And if you rearrange this formula, we can write the wavelength of the light can be calculated by AX over D. A is the slit separation, X is the fringe separation, and D is the distance between the slits. It is distance between the slits and the screen. So it seems that from this formula, from this one, if we increase the wavelength of the light, the fringe separation will increase. They are directly proportional. If we increase the distance between the slits and the screen, this D, again the slit separation is going to increase. The only way to decrease the slit separation is to decrease the distance between the two slits. This is A. Okay, that's it for the formulas of the double slit experiment. Next lesson we are going to solve some problems related to the double slit experiment. Thank you for listening. See you next time.